Okay, this is on algebraic proof. Make sure you spell it right. It's algebraic proof. And we're going to review some of the properties from your Algebra 1. First thing the author goes through in this section is properties of equality for real numbers. And in the book, they use an italic R for real numbers. I always use a double bar R. Okay, when you see that, that stands for real numbers. Real numbers are everything on the number line. The irrationals, the rationals, everything. Okay, so when you see that, it's just a double bar R. That stands for real numbers. Everything on the number line. Okay. Okay, there are three properties, okay, that are properties of equality. First one is reflexive. And the reflexive property says for every real number, and any place I say real number, if you want to put a double bar R, you can. For every real number A, and this is the property, A equals A. That means like a number equals itself, like 5 equals 5 would be the reflexive property. It would also be like, as an example, like if I said 5 equals 5, that's reflexive. If I said 1 plus 4 equals 1 plus 4. If I said 7 minus 5 equals 7 minus 5, it equals itself. Just because this is one letter here, it does not mean that it's one number. It can be replaced by more than one number. But it's anything equals itself. Okay, that's the reflexive property. Okay, the next one is symmetric. Am I right? You've heard of these? Yes. So this should be reviewed. And if you want to abbreviate property, just do PROP. That's good enough. And that says for all real numbers, just use a double bar R for all real numbers. And down the road, those of you that go into higher level math, for all is this symbol. It's the upside down A. The upside down A, it means for all, for every, for any. Okay? Okay, for all real numbers, A and B. Okay? If A equals B, then B equals A. And the symmetric property is always an if-then. Okay? It's an if-then statement. And notice the A and the B turn around an equal sign. Okay? Now, just because it's one letter does not mean it's replaced by one number. So, an example, it could say if 2 plus 3 equals 5, then 5 equals 2 plus 3. My A would be 2 plus 3, my B would be 5. Another example, if I said if 10 divided by 5 equals 2, then 2 equals 10 divided by 5. Okay, that's the symmetric property. Okay, symmetric. Okay, and the last one, reflexive, symmetric, and transitive. And the transitive property, okay, says for all real numbers A, B, and C, for all real numbers A, B, and C, okay, if A equals B and B equals C, then A equals C. Transitive property will always have 3 equal signs. And it's still in an if-then statement. Transitive property has 3 equal signs. So, an example. If I said if 5 equals 1 plus 4 and 1 plus 4 equals 2 plus 3, then my A is 5, so then 5 equals 2 plus 3. That's an example, okay, of the transitive property. Okay, so those are all properties. They all have that general name. They're all called properties of equality: reflexive, symmetric, and transitive. Okay, now if you want to draw a little separator here. Okay, the next one, and you've had these before too, but you need to have these properties for the proofs that we're going to do. Okay, the next one is the addition and subtraction property. Addition and subtraction property. And it says for all real numbers A, B, and C. Okay, and the property says this: if A equals B, then, now this is the property that says I can add something on both sides of the equation. Then A plus C equals B plus C. I'm adding C to both sides of the equation. That would be the addition property. And the subtraction would be A equals B. Then if those two are equal, then I should be able to subtract the same thing on both sides. Didn't write that very good. Okay, if A equals B, then I should be able to subtract C on both sides. Okay, and that's the subtraction property. Okay, draw another little separator. Write them all down. Okay, I'm just kind of refreshing your memory. Okay, the multiplication and division. The one term in here that you cannot abbreviate. Okay, this is the one term that you can't abbreviate, is subtraction. Okay, because it's too hard to tell if you meant subtraction or substitution. So don't abbreviate subtraction. The multiplication division property says for all real numbers A, B, and C. Okay, and here's the property: if A equals B. Okay, the multiplication one said, well, sorry, I said it, but I wrote the wrong thing. If A equals B, multiplication is the one that says you can multiply on both sides. So then AC equals BC, and multiply by the same number on both sides. And the division one, if A equals B, then A divided by C equals B divided by C. Without these properties, we could not solve equations. Okay? So we've got to have them. Okay? Okay, and then substitution. This is another one that I don't want you to abbreviate. Subtraction and substitution are ones that you need to write out because it's too hard for the grader to figure out which one did you mean. Okay? The substitution property. Okay, and it just says for all real numbers A and B. For all real numbers A and B. If A equals B, then A may be replaced by B in any equation or expression. Now that would be something like if I said 3 times 5 is 15, and then later on I substitute 15 in for 3 times 5. Okay, that's the substitution principle. Okay, That's not multiplication, because multiplication you got to show that you're multiplying by the same thing on both sides. Okay. Okay, another property that I'm sure you've all had is distributive. And the distributive property, use this a bunch for all real numbers A, B, and C. A times the quantity. Whenever it's in parentheses, read it the quantity times the quantity B plus C. Okay, and I usually show the arrows, multiply that out, so that'd be AB, multiply this out, plus AC. Okay, and that's the distributive property. Okay, you do have to pay attention to the positive and negative signs when you're multiplying that out. Like if I said something like this, if I said negative 8 times the quantity 2x minus 5y. Okay, I'm going to use the distributive property. There's no sign in between the negative 8 and the parentheses, so you're going to multiply this out, and it's a negative times a positive, it'd be a negative, and then you have a negative times a negative, it'd be a positive. Okay, so you do have to pay attention to the signs when you're multiplying it out. Okay, okay, those properties now, and the postulates that you've used, and the theorems that we've had one theorem, the midpoint theorem so far. Okay, we're going to use those to go through two-column proofs, a formal two-column proof. Okay, so I want to go through an example of that. This is an example of a two-column proof. Now, in the written part of the book, it will say prove. Okay, we're not doing the paragraph proofs. We're doing two-column proofs. We'll say prove if 7x plus 3 divided by 4 equals 6. Then x equals 3. Now normally we would just say solve that, okay? But this is a formal two-column proof. So on your paper, 2 columns. Okay, on the left side we're going to put statement, and on the right side is the reason. Now normally on the first one, it's usually the given. The hypothesis up here, this part is the given. Okay, and then we want to prove it equals 3. So start out with 7x plus 3 divided by 4 equals 6. It says if this is true. Okay, so the reason is just called given. Okay, the first step, and then you just basically go through how would I solve this. The first step on this, you want to get the 7x plus 3 by itself, so you have to get rid of the 4. Multiply by 4 on both sides. So if we multiplied by 4 on both sides, okay, and we just went through the property. And it's okay. I'm okay on abbreviating all of them except substitution and subtraction. Okay, so that's just called multiplication property is the reason. Third step. Okay, the 4's on the left would divide out, and you'd have 7x plus 3 equals 24. Now, when you're doing a two-column proof, you really need to look from this line down to this line. You have to say, what they do from line 2 to line 3? 6 times 4 is 24. What property? Look back up. We already did multiplying. Multiplying is where you multiply on both sides. We multiplied by 4 on both sides. Substitution. Okay? So this reason, 6 times 4, we're substituting 24 in for 6 times 4. And this is the one I don't want you to abbreviate. and you do have to learn how to spell it. Okay. Okay. Now we're just solving this, so we want to get the 7x by itself. Subtract 3 on both sides. Now I don't care if you go on this line or if you go underneath. Some of you like to go underneath, and that's probably how I would do it if I was actually solving it just as an equation. So what property says that I can do this on both sides? Subtraction. So that is the subtraction, and you can abbreviate property. Okay. Okay, then on the next line we'd have 7x equals 21. Careful, we got to give a reason here. What property says we go from this to this? Substitution, yep. Okay, and then somebody said it. What's the next one? Substitution. I spell right. Okay. Divide by 7 on both sides. And that's the division property. You can abbreviate it. Okay, and then from that line, we'd have x equals, and what property says we're going from here to here. Yep, substitution. Okay, so when you're doing these, you go from your step above to the next step, but you really have to look back one step and say, what did I do from here to here, and then what property is that? Okay, any questions on that one? Okay, now on the homework, okay, if you look on the ones for Friday, go to number 17. Yeah. Is that on page 359 or 360 on your iPad? Okay, go to page 359, number 17. What do you need? Where for? Okay. Okay, on number 17 on page 359 on your iPad. Okay, it is basically the same idea. Now, so that you have examples to study, okay, when you write this out, you write it out just the way we did in the notes. I don't want you to just fill in the blank. I want a statement and a reason right beside it. The author's been nice enough to give you the statements, except for B, okay? And it would help your grader if you go ahead and underline it or put a box around the answers. Probably just underline it, okay? But write out both sides, just like we did here in the notes, okay? Everybody hearing that on 17? Okay, it's that way on 17. It's that way on 18. I want to see the whole thing, both sides all the way down. And it would help the grader if you go ahead and underline it or highlight it, something. Okay, then that will be the third one going through where you've had a guide. Okay, then on number 20, okay, 20, you have to do it all on your own, line by line, statement and reason. Okay? Okay, so 17, 18, and 20, you write them all out. Okay? On the others, I think you just list the property. Just the abbreviation is fine. If you want to say multiplication property like we did up here, substitution, okay, don't abbreviate subtraction and substitution. Write those out. Okay, I'll give you time to work.